My name is Greg Shaver. I'm a professor of mechanical engineering and also the director of the Ray W. Herrick laboratories. Yes, so the most important emissions that come out of diesel engines that are used for lots of in-use applications, including freight and people moving applications both on and off-road, are CO2 emissions, NOx emissions, and soot or smoke emissions. The CO2 emissions are driven by the combustion of hydrocarbon fuels in the engine. And all three of these are important to try to reduce to the extent possible and are regulated by the government. So there is an inherent relationship between our ability to reduce soot emissions, smoke emissions, and fuel consumption or CO2. But we can improve that trade-off and allow simultaneous reductions in all three if we add some additional advanced technology to the engine itself. And so some of that technology, specifically cylinder deactivation and variable valve actuation, are advanced technologies that we've been developing and demonstrating here at the Ray W. Herrick Labs together in collaboration with and support from our sponsors. Yes, so one of the technologies we've developed to simultaneously reduce NOx emissions and reduce fuel consumption and CO2 is cylinder deactivation. And so this engine, like the one that's here behind me, we can make it act smaller when we need to produce less power. So we can, instead of running all 6 cylinders and all 6 cylinders producing basically power, we can have 3 or 4 or maybe even 2 of them produce power. And by making this engine act smaller by deactivating some of the cylinders, we can reduce fuel consumption and CO2 and also generate less NOx out of the engine, while simultaneously maintaining and achieving exhaust temperatures coming out of the engine that allow the after-treatment catalysts that help reduce the NOx emissions stay up at the temperatures they need to be at.